Hi, in this video we will see how do we perform the long division of polynomials. In one of my previous videos, I have explained how do we perform the synthetic division, and I have told that synthetic division is basically a shortcut to long division. Okay, so let us see what is the difference between synthetic division and long division. Synthetic division and long division. A very important difference between synthetic division and long division is that synthetic division is applicable only when the degree of the divisor function or the divisor polynomial is 1. This means that it is a linear polynomial. Fine. And the other condition for using synthetic division is that the coefficient of x or the leading coefficient of the divisor should also be 1. Okay, these were the two conditions. If these are satisfied, then only we can apply synthetic division. Okay, synthetic division is very algorithmic and there are lots of steps which we need to remember. But a long division is a general method to perform division on any two polynomials. Irrespective of whether the divisor polynomial is a linear or it's non-linear, whether the leading coefficient is 1 or any other number. So long division is a very powerful technique to perform the division of two polynomials. Now let us learn this long division by taking an easy example first. So suppose we have a function p of x or a polynomial p of x which is x plus 3x square minus 1. And we have another polynomial g of x which is 1 plus x. We have to divide p of x by g of x. We have learned long division method in our primary school when we used to divide two numbers by long division. So in this case also we will be writing the divisor and the dividend the same way. So here px becomes the dividend and gx becomes the divisor. Okay, now there are certain steps which we need to follow before performing the long division. Arrange the polynomial functions, arrange the polynomials in descending order of powers. That's the first step. Okay. So px is x plus 3x square minus 1 and we will be arranging it in descending order of the powers. So we'll write x to the power 2 terms first, then the x term and then minus 1. Similarly, g of x is 1 plus x. It has again to be arranged in descending order of the powers. So it will be written as x to the power 1 plus 1. I hope this much is clear. Now let us begin the division. So we have 3x square plus x minus 1 as the dividend. We write it the same way we used to perform the long division with the numbers. Dividend here and the divisor outside x plus 1. We have to take it in the descending order of the powers. Now take the first term of the dividend. So the first term of our dividend is 3x square and the first term of the divisor is x. First step is to divide 3x square, which is the first term of the divisor, by x, which is the first, 3x square, which is the first term of the dividend, by x, which is the first term of the divisor. So 3x square over x basically gives us a 3x. So this means that x, which is the first term of the divisor, has to go 3x times to give us a 3x square, right? So this 3x will be the first term of our quotient. So we write 3x here. Okay, this is a step 1. In step 2, we have to multiply the first term which we have got in the quotient, which is 3x. So this 3x has to be multiplied by each term of the divisor. Okay, so this 3x has to be multiplied by x and has to be multiplied by 1. So 3x multiplied by x gives us a 3x square, and 3x multiplied by 1 gives us a plus 3x. We write this below the like term. So I write a 3x square here and a plus 3x here. We know that we used to perform the subtraction while doing long division with numbers. The same thing we will do. We will try to subtract this term. So 3x square minus 3x square gives you 0, and 3x minus 3x gives you a negative 2x. Okay, and we have to bring down minus 1 here. Now let us see what do we do now. So again, our new dividend in this case becomes minus 2x and minus 1, and it has to be divided by x plus 1. So we will repeat our step 1 again. This was our step 1 where we divided the first term of the dividend by the first term of the divisor. So we will do minus 2x divided by x, which gives us a negative 2. This means that the second term of our quotient is negative 2. Okay, and now this negative 2 will be multiplied to each term of the divisor. So minus 2 into x gives you a minus 2x. Like terms below like terms you have to write, and minus 2 times 1 gives you a minus 2. And we have to perform the subtraction. So when we subtract, minus 2x minus of minus 2x basically gives us a 0, and minus 1 minus of minus 2 is basically minus 1 plus 2, which gives us a plus 1. Now ask yourself a question. Can 1 be divided by x? No, x plus 1 has a higher degree. The degree of x plus 1 is basically 1. Degree is the highest power of the variable, and here the degree of a constant is always 0. There is no x term here. Degree of whatever is remaining here becomes less than the degree of the divisor. It is less than the degree of divisor. That's when we stop our division. So we have to stop our division. So it means that this is the divisor. The degree of divisor is 1. This is the remainder. In this case, remainder, it is the remainder because the degree of it is 0, which is less than the degree of divisor, and that is when we stop our division. 3x minus 2 is the quotient polynomial, and this is anyways our dividend polynomial. We see that 3x square plus x minus 1, which is our p of x, when it is divided by g of x, which is x plus 1, we get as the quotient and 1 as the remainder. Okay, so 3x square plus x minus 1 whole upon x plus 1 is equal to 3x minus 2, which is our quotient, plus 1 upon x plus 1, which is our remainder. I hope this representation of the two polynomials in division is clear to everyone. In our next video, we will see a little bit more difficult example of dividing two polynomials by long division. If you have any doubts regarding this, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel Mathacademy. If you have liked my videos, please don't forget to like, share and subscribe. Thank you.